All right, this is the second lesson in the 2D geometry unit. It's central angles and sums of angles. This is the homework that goes along with it. All right. Some notes. One thing that I want you to add to your notes is a regular polygon. That word regular means a polygon that all sides are congruent or the same. I've drawn a picture here. A regular triangle is an equilateral triangle because it's got 3 equal sides and 3 equal angles. A regular quadrilateral would be a square. Now, in class, I'm going to give you a piece of paper that gives you the names of all the polygons. A quadrilateral has 4 sides. A pentagon has 5, a hexagon 6, etc., and so on. You do need to know that. And this picture right here is a pentagon. And I drew a point right in the middle, and to show you that these, whoopsie, I don't want to do that. These angles right here are the central angles, and that's what we're looking for. It's the angle in the middle. Now, it's actually pretty easy when you have a regular polygon, because if you think about it, the whole way around this circle in the middle is 360 degrees. Because if I drew a straight line, there's 180 degrees on this side and 180 on that side, so it's 360 the whole way around. So to find the measure of any central angle, all you need to do is do 360 divided by n, which is the number of sides. So, what's the central angle of a triangle? 360 divided by 3 is 120. The central angle of a hexagon. A hexagon has 6 sides, so 360 divided by 6 is 60. The central angle of this polygon. Now, if I count these sides, I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 sides. So 360 divided by 10 is 36 degrees each. And I drew a picture here. These are the angles that we're talking about, the central angles. All right. This is a review for some of you. For some of you, it'll be new. The sum of the interior angles in a triangle is 180 degrees. So every triangle in the world has 180 degrees in it. And the quadrilateral has 360 degrees in it. And I drew a square here, or a rectangle, whatever. I split that into 2 triangles. If this one has 180 and this one has 180, it's 360. Not to mention the fact that if you think about a square, doesn't a square have 4 right angles? That would be 4 times 90 is 360. All right. So, this is a quadrilateral. How do I write an equation to solve for x? Well, x plus 63 plus 107 plus 42 is 360, because there's 360 degrees. And I can solve that and get 48. Here's a triangle. We know that the 3 angles in a triangle add up to 180. So I end up with x is 71. Now, these are a little bit more complicated. The original angles are written in black. This is a quadrilateral. So when I solve this, I'm going to take 3x plus 5x plus 5 plus 2x plus 5x plus 25, and I get 360. And when I solve that equation, blah, 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 you can pause this and write it, you end up with x is 22. Now, once I know that x is 22, I'm going to go back in here, plug it in to each one of these expressions to find out how big each angle is. So this will be 2 times 22 is 44. This will be 5 times 22 plus 25 is 135 degrees. 3 times 22 is 66. 5 times 22 plus 5 is 115. And if I add 44, 115, 66, and 135 together, I will get 360. All right. Take a look at this in the black. It's a triangle. So my equation is 7x plus 30 plus 3x plus 2x equals 180. When I solve that, I end up with x is 12.5. Once I know that x is 12.5, I can use that to go back in and find the 3 angles. And to check, I can add them and I will get 180.